Algebra Lesson 8-1, 0 and negative exponents. Let's review exponents for just a moment. If you remember, an exponent tells you how many times to use the base as a factor. So here in letter A, we have 2 to the third, which means 2 times 2 times 2, which, contrary to popular belief, is not 6. It's not 2 times 3. It's 2 times 2, which is 4, times 2, which is 8. Letter B here, we have 1 over 4 squared, which is 1 divided by 4 times 4, which is 1/16. Letter C here is not negative 3 to the third. It's the opposite of 3 to the third power, which means it's like this. The negative goes on the outside, and it's 3 times 3 times 3, which coincidentally, negative 3 to the third power and the opposite of 3 to the third power would be the same number. But if you take them to an even numbered power, that would not be the case because we would have a different number of negative signs. So 3 times 3 is 9, 9 times 3 is 27, so this is negative 27. That's just a review of working with exponents. Now, since an exponent tells us how many times we can use the base as a factor, let's take a look at a couple of problems here. 3 to the third power is the same thing as saying 3 times 3 times 3, which is 27. 3 to the second power is the same thing as saying 3 times 3, which is 9. 3 to the first power is 3, because we use 3 as a factor one time, which is 3. Now let's just take a look at these three numbers for a moment. If you look at it, each time, you should notice that you're going down by a factor of 3. In other words, you're dividing by 3, because 27 divided by 3 is 9, and 9 divided by 3 is 3. So if that pattern continues, if I divide by 3, and then I divide by 3, and then I divide by 3 again, 3 divided by 3 is 1. So if we take 3 and divide it by 3, 3 divided by 3, 3 divided by 3 equals 1. And 3 to the 0 power does equal 1. 3 to the negative first, you still have to get smaller, but we can't get a negative number because it's not a negative 3, it's 3 to the negative first power. So 3 is still our base. So we're still using our 3 as a base. Okay. So if we divide by 3 again, if you think about this, if we take 1 and we divide it by 3, we're going to get 1/3. And if you take 1/3 and divide that by 3, it's the same thing as saying 1/3 times 1/3, which is 1/9. Each time we divide by 3. We divided by 3 here, we divide by 3 here. If you look at these last two, okay, 3 to the 0 power gives us one property of an exponent, and 3 to the negative first and 3 to the negative second give us a different property. If we look at the last two problems here, 3 to the negative first and 3 to the negative second, if I look at those, okay, 3 to the negative first power ends up to be 1 over 3, or 1 over 3 to the first power. 3 to the negative second becomes 1 over 9, or 1 over 3 to the second power. So if you look at this carefully, you'll see that if you take a number to a negative exponent, that's the same thing as saying 1 over that number to the positive exponent. This leads us to two very special properties of algebra. Okay? 0 as an exponent, that property, and the negative exponent property. 0 as an exponent says for every non-zero number a to the 0 equals 1. For example, anything to the 0 power, with the exception of 0, is 1. 5 to the 0 power is 1. Negative 2 to the 0 power is 1. Doesn't matter if it's negative or positive. 1/3 to the 0 power is 1. 4,556,210 to the 0 power is 1. Any number to the 0 power is 1. And for negative exponents, for every non-zero number a and integer n, a to the negative n, which means if you take a number to a negative exponent, that's the same as having 1 over that number to a positive exponent. So here you have 6 to the negative fourth is the same as writing 1 over 6 to the fourth power. And to make that exponent positive, it has to move to the denominator, because that's how you tell somebody that something is getting smaller and make it a fraction. So How do we apply these? Well, let's take a look at some. For algebra, expressions are in simplest form when they're written only with positive exponents. If the expression is a fraction in simplest form, the only common factor of the numerator and the denominator is 1. So if you ever see something that says simplify, that means reduce it as far as it will go, make sure it only has positive exponents. So if we look at number 1 here, you might say, but it is simplified. Truly, it is not simplified, because when we look at it, it has a negative exponent, and we need to simplify it. So 3 to the negative second is the same thing as saying 1 over 3 to the second power, which is the same thing as saying 1 over 9. 1 over 9 is in the simplest form. Negative 7 to the 0 power. Well, the property of exponent tells us anything to the 0 power is 1, so the answer to this is just 1. Not negative 1, just 1. Negative 4 to the negative third means I have 1 over negative 4 to the third power. Okay, it's a negative 4. The negative only changes on the exponent. When you move an exponent to a negative exponent to the denominator, that negative exponent becomes positive. The number itself stays negative. That's why we still have a negative 4 there. So this is the same as saying 1 over negative 4 times negative 4 times negative 4. 4 times 4 is 16. 16 times 4 is 64, so this becomes negative 164. Don't lose your negative sign. You have 3 negative signs, it stays negative. 3ab to the negative second power. Now, in this particular problem, the only thing taken to the negative second power is the b. It's the only thing taken to the negative second power. Okay? So the 3a needs to stay in the numerator, because it's like saying 3a over 1 times 1 over b to the second power. The 3 and the a are both positive exponents, because when a number doesn't have an exponent, the exponent is expected to be a 1. It's an implied 1. So the 3a stays in the numerator, and the b to the second goes to the denominator, just like that. All of those are simplified. Nothing can be reduced any further, and all the exponents are positive. Let's do some more. Make it a little bit more complicated. 1 over x to the negative third. Now x to the negative third is the denominator. If I have a negative exponent in the denominator, to make it positive, I need to move it back to the numerator. If it's in the numerator to make it positive, you move it into the denominator. If it's in the denominator to make it positive, you move it in the numerator. Because basically I can rewrite this as 1 over x to the third. I have a complex fraction. 1 divided by 1 over divided by x to the third. Well, hopefully you remember with fractions, 1 over 1 times the reciprocal, x to the third over 1. So this becomes x to the third. So you soon learn that if you just move it to the numerator, it changes its sign. If something is negative and it's in the numerator, to change its sign, move it to the denominator. If something is negative and it's in the denominator, to change its sign, move it to the numerator. Number 6, the only thing that's negative is my m. So my 11 stays in my numerator, and my m to the 5th moves to the denominator. And I'm done at this point in time because I cannot reduce it any further than that. Okay. Number 7. 7 is positive. T squared is positive. But s to the negative 4th isn't, so that becomes multiplied by 1 over s to the 4th. So you basically have 7t to the second divided by s to the 4th. And that is as simplified as it gets. Number 8, n to the negative 5th divided by b to the second. N to the negative 5th is a negative exponent, so that becomes 1 over n to the 5th. And we're going to multiply that by 1 over b squared. Because the b is already in the denominator, which means the numerator has to be 1. If you have something in the denominator and you don't have a number in the numerator is always 1. So this becomes 1 over n to the 5th, b to the second. And we normally write these so that your exponents, your variables, come in alphabetical order. So you write n's before b's just because alphabetically n's come before b's. Now, when you go to substitute in numbers, you just have to be really careful to make sure that when you substitute a number in for a variable, substitute it inside of parentheses. If you don't put it inside parentheses, then you're going to accidentally introduce a negative where you don't need to, or accidentally forget a negative where you do need it. So if I have n to the negative third w to the 0, I can either simplify this first to make all the exponents positive first, and then substitute the numbers in, or I can substitute the numbers in and then make all the exponents positive. It's either way. So if I looked at this, n to the negative third becomes 1 over n to the third, and w to the 0 becomes times 1. So I now have 1 over n to the third. Now I can substitute in for what is n. N is negative 2. So that becomes 1 over negative 2 to the third power. So that becomes 1 over negative 8, or negative 8. You can simplify first, then substitute in, or substitute in first and then simplify. I tend to like to simplify first because once you start getting lots of numbers with lots of negative signs, it can get very confusing. So number 2 here, the n to the negative first is negative. So that's going to become 1 over n to the first times 1 over w to the second. So basically 1 over n times w squared. So that's 1 over n, which is negative 2, times w squared, which is 5 squared. So I have 1 divided by negative 2 times 25, which equals 1 over 50. Step by step, show your steps. Don't skip steps because that's when you'll start getting lots of negative 1/50. That's where you'll get a lot of errors because you'll skip steps and you'll miss something, and then that would be bad. Number 3, anything to the 0 power is 1, so I have 1 over n to the 4th. I now have 1 over n happens to be negative 2, negative 2 in parentheses to the 4th power, because if I don't put it in parentheses, that means the opposite of 2. And even if you put it on your calculator is going to evaluate it exactly how you tell it to, not necessarily what you want it to do. So 2 to the 4th power, 2 times 2 is 4, times 2 is 8, times 2 is 16. So this becomes 1/16, and it's positive because I have an even number of negative signs. I have 4 negative signs, which makes it positive. And last but not least, number 4 here, 1 divided by n w to the negative 2nd power. Okay, that's 1 over n times w to the 2nd over 1. So in other words, it's w to the 2nd over n. W is 5, so I have 5 squared over negative 2, which becomes 25 over negative 2. And I can leave it as an improper fraction like that, or I can change it to negative 12.5. Doesn't matter. Either one works. So this is either negative 25 halves or negative 12.5. I personally prefer negative 25 halves, because most of the time to check something, I'm going to have to put it back in the improper fraction anyway. So I don't like to have to take it back out and put it back in. All right, let's do a real-world problem. In the lab, the population of a certain bacteria doubles every month. The expression, oh, my expression is missing. I hate when my expression is missing. That should be 3,000 times 2 to the m. Let's put that in there. A little asterisk here. The expression is 3,000 times 2 to the m power. In the lab, the population of certain bacteria doubles every month. The expression 3,000 times 2 to the m models the population of 3,000 bacteria after m months of growth. Evaluate the expression for m equals 0 and m equals negative 2. Describe what the value of the expression represents in each situation. All right, so I have to do this twice. Okay, so I'm gonna solve this when m is 0, and then I'm gonna solve it again when m is negative 2. So here's my expression: 3,000 times 2 to the m power. So when m equals 0, I will have 3,000 times 2 to the 0 power. Anything to the 0 power is 1. So this is 3,000 times 1, which is 3,000. For m equaling negative 2, I'm going to have 3,000 times m to the negative 2nd power. Excuse me, times 2 to the negative 2nd power, not m, times 2 to the negative 2nd power, which means 3,000 times 1 over 2 squared, which is 3,000 divided by 4. 3,000 divided by 4 is 750. Now, it says, describe what the value of the expression represents. Basically, when m equals 0, the value is 3,000. This represents the initial population. Okay, this is the beginning of the population of your bacteria. So when m equals 0 is your initial population. Of 3,000 bacteria. When m equals -2, that represents the bacteria, what the population of the bacteria was 2 months ago. Okay? M equaling -2 is the population of the bacteria 2 months ago. Which was 750. Which makes sense because if your bacteria is doubling every month, 2 months ago it should be a lot smaller than it is now. This is the initial population of bacteria, 3,000. My 2 months ago bacteria was 750. This is working with negative exponents and 0 as an exponent.